to look up the description of a specific ice cream flavor, say mango ice cream, and you don't remember what's the number or index associated with this, it's pretty hard to pull up this description of mango ice cream. So dictionaries in Python are inspired on Aardvark, and then the definition of that word, and then another word, like say apple, and then a description or a definition of what is an apple. There is a similar mapping from words to definitions, except that we call them keys and values. So for example, you might have a key which captures the concept of mint chocolate chip ice cream, and that maps to a description of that flavor. And a different key, cookie dough, may then map, in this case, to the description of the cookie dough. Here's the Python snippet of code you will use to define a dictionary, where here we're setting ice cream flavors to be a dictionary where mint chocolate chip maps to this description, cookie dough maps to this description. Let's walk through all the components of this code in detail. What I've highlighted in blue here are the keys of the dictionary, and highlighted in orange here are the values. And in a dictionary, different keys, the ice cream flavors, map to different texts. Of that item, then it can be hard to access the pull of that one item. There's another kind of way to organize collections of data in Python called a dictionary that makes it much easier to pull out one specific item from your collection of data. We'll learn about that in this lesson, and we'll also see a fun example of using a dictionary to prioritize things on your to-do list as maybe high functions as usual. And then I'm going to use the example of ice cream descriptions. Vanilla's classic and creamy with a rich, smooth flavor, and so on. The problem with using this is if you want to look up the description of a specific ice cream flavor, say mango ice cream, and you don't know what's the number or index associated with this, it's pretty hard to pull up this description of mango ice cream. So dictionaries in Python are by real-world dictionaries that people use to look up the meanings of words. So in a paper dictionary, maybe you'll have a word like word, and then another word like say apple, and then a description or a definition of what is an apple. In Python, there is a similar mapping from words to definitions, except that we call them keys and values. So for example, you might have a key which captures the concept of mint chocolate chip ice cream, and that maps to a description of that flavor. And a different key, cookie dough, then you will use to define a dictionary, where here we're setting ice cream flavors to be a dictionary where mint chocolate components of this code in detail. What I've highlighted and highlighted in orange here are the values. And in a dictionary, different keys, the ice cream flavors, map to different values, in this case, the descriptions. Notice that keys and values are separated by colons. And here, ice cream flavors is the name of this dictionary that we're defining. Equal is the usual assignment operator. And to define the dictionary, you use curly braces, or to start and end the definition of the content of the dictionary. And we also have commas separating out the different, I'm going to say ice cream flavors equals, because I'm defining a dictionary brace. And for this example, let's just use 3 flavors: mint chocolate chip, then cookie dough, colon, description of that, and finally salted caramel. And then to brace, and then hit Shift Enter. And now I've defined ice cream flavors as my dictionary. Keys like these, and values like this text here on the right. And the different lines are as before. separated by commas. So I'm going to point out again some key differences between dictionaries and lists. First, as you've seen, instead of using a square bracket, we use curly braces. And then second, strings per line instead of a single string per line. And these two strings are the key and then the value, which is the second string, and is separated by a colon. Because dictionaries have keys and values, where each of these lines has a key value pair. If you want to look at these, I can print ice cream flavors dot keys, like so, and this prints out the three names as expected. And if you want values, then we can run this, and this prints out the dictionary's values. Now, dictionaries might look a bit like lists, but they behave differently. If you were to try to access the first item in this dictionary via, say, print ice cream flavors 0, this won't work because there is long list can be a good way to store a lot of data. They behave differently. If you were to try to access the first item in this dictionary via, say, 0th element, so let me hit Shift Enter, and this generates a single item in this dictionary. Let's try asking our chatbot. It says cookie dough description equals ice cream flavors, square, and print cookie dough description. Let's give it a try. I'm going to copy this code and go back to my Jupyter notebook and paste that in, and let's run that. And there you go. It printed out the description: vanilla ice cream loads of chunks of chocolate chip cookie dough. So the code to access a specific item of the dictionary is to have the name of the dictionary, ice cream flavors, and then these are square brackets. A bit confusing. When defining the dictionary, you use curly braces, not square brackets. But after you've created the dictionary, you're accessing a specific item in the dictionary, you use square brackets. And then in here is one of the keys. And what the dictionary will do is look up if there's a key that says cookie dough. And if so, it then returns or passes back the description, that is the value associated with this key, and it stores that in the variable cookie dough description. And so when it prints out, we got this description of cookie dough flavored ice cream. Let's look at how we can add an item to a dictionary. Let's add to this dictionary a description of Rocky Road flavored chocolate. So here's my dictionary, print ice cream flavors, and there's chocolate chip, cookie dough, salted caramel. And if I want to add a description of Rocky Road, I would say ice cream flavors, square bracket, not curly braces, Rocky Road equals, and then, here's the description. And if I now print out again, ice cream flavors is now expanded my dictionary to also have Rocky Road as a new key that maps to this description, chocolate ice cream mixed with other ingredients. But wait, we have a few spelling errors here. And it turns out the same pattern can be used to update the value of a certain item in your dictionary as well, where if I rerun this code, chocolate ice cream mixed with other ingredients, let's run that. And if I print ice cream flavors, then now I get an updated description that has the errors fixed. Now, it turns out dictionaries can hold all sorts of data. In the example we used, we had ice cream flavors mapped to a description of the ice cream flavor, but dictionaries can also map to numbers instead of to strings. So, for example, if I want to create a dictionary of facts about Isabel, that her age is 28, her favorite color is red, then I can construct a dictionary like this and remember as a curly brace to build the dictionary. And here, the key age maps to, or colon, maps to number 28, and favorite color maps to another string. And if I print Isabel facts, I end up with this dictionary, where one of the values is a number, is an integer, and one of the values is a string. So dictionaries can map the keys to different types of data, in this case, strings or numbers. Now, if Isabel has 3 cats, I will store the name of all of her cats. Well, one thing I might do is create a list. And so here's a list. I've created a list with a square bracket, and then Charlie, Smokey, Tabitha as the name of her 3 cats. But how do I? Well, one thing I could do is create an extra key, Isabel facts, square bracket, cat name, list of 3 cats. And so in this example, I'm taking the Isabel facts dictionary, creating a new key, cat names, and instead of cat names mapping to a single string, like red, or a single number, like 28, this key, cat names, now maps to a value, where the value is itself a list of all 3 cats' names. So let me do that. And let's now print Isabel facts. And you see that this is a dictionary where age maps to 28, favorite color maps to red, and cat names map maps to a list. And here's another example. I can set Isabel's favorite snacks to pineapple cake and candy. And if I then print Isabel facts, favorite snacks is pineapple cake and candy. Before we wrap up this video, I'd like to just go through one fun example of using a dictionary of and complete high priority tasks. You previously a list to keep track of a set of tasks. And that was one fine way to do. But let's level up our personal organization game. And let's take these tasks and store it in 3 that organize our tasks by priority. And so high priority tasks is a variable that has stored a list of these 2 items. Medium priority task is a variable that has stored a list with these 2 items. And similarly for low priority tasks, there's a list with just a single item. Now, let's create a dictionary to put these 3 lists inside the dictionary. So I'm going to say prioritize tasks equals curly braces. And then I'm going to create a key high priority colon high priority tasks, comma. And so what we just did is create a key that's the string high priority, and the value that this key maps to is high priority task, which is this variable that we just defined up here. And similarly, I'm going to create 2 new keys. Medium priority is a key that maps to this list of medium priority tasks that we defined up here. And same for the key low priority. Close out the braces, and let me now print out prioritize tasks. And now you see this is a dictionary where high priority is a string that maps to this list of 2 items. Medium priority is a string, large language model, to do the high priority. I can look up the high priority task by looking up prioritize task high priority, like so. And I could actually print this out. And so this prints out the 2 tasks, compose a brief email, and create an outline for a presentation. So prioritize tasks with the key high priority is a list of 2 items. And if you remember what we had seen in the previous lesson with the for loop, let's see if we figure out what this might do. I'm going to say for task in, and then prioritize task high priority. Remember, we need a colon here, and then indent 4 spaces, and then let's print on response task. Shift enter. And so this composes a brief email, and then create an outline for a presentation on remote work. And if you want, feel free to edit this code to have it then do your medium priority or your low priority tasks for you as well. So you've learned a lot about dictionaries and lists. In the next lesson, we'll go further with dictionaries and use the key value pairs, specifically the values of the dictionaries, to create customized prompts for a large language model. As you've seen, dictionaries and lists are both useful ways to organize data. In this lesson, I'd like to go through with you a fun example about storing your friends' food preferences in a list or a dictionary or a combination of both, and then using that as data to customize a prompt to get AI to suggest recipes for your friend. This gives us a more sophisticated way to store data and use that data to customize a prompt that's fed to a large language model to then generate some pretty interesting and hopefully delicious outputs. Let's take a look. So I'm going to define a dictionary to store the food preferences of Tommy. Remember, we're using curly braces here because it's a dictionary. Then the key dietary restrictions maps to the string vegetarian. Favorite ingredients maps to a list of 2 favorite ingredients, tofu and olives. This is his experience level as a chef, and maximum spice level, 6 on a scale of 10. So let me run this first cell and the second cell. And you notice that this dictionary has 4 keys as well as 4 values. And the first value is a string, second value is a list of strings, the third value is a string, and the fourth value is just a number. Just as we saw in the previous lesson, if you want, you can print out the keys of this dictionary, and you can also print out the values of this dictionary, like so. Now, if I want to recommend a recipe for Tommy to try out, I could use a prompt like this. So this says, please suggest recipe that tries to include the following ingredients. And then this is an F string, so I have curly braces as usual for an F string, and then food preferences Tommy, which is the dictionary we defined up on top, square brackets to look up the value associated with the key favorite ingredients. So this should plug in tofu and olives. Recipe should adhere to find dietary restrictions, to look up Tommy's dietary restrictions. Difficulty of recipe should be, this should be pull up the value intermediate as his experience level. And then the maximum spice level on a scale of 10 is 6, and to provide a 2-sentence description. So let me run that. And if you want, you can actually take a look at what this prompt looks like. And here's the prompt. And you see that all the values in the curly braces in my F string have been filled in by pulling the right pieces of data from the food preferences Tommy dictionary. And if we now print our response, we then end up with this. Try to make it Mediterranean tofu and olive stir fry, sauteed cube tofu with bell peppers. I don't know, sounds pretty good, and both of his favorite ingredients. Feel free to pause the video and plug in your own favorite of any and so on, and see if this gives a result to your liking. All the data we have so far relate to Tommy's food. So it makes sense to create a variable, in this case a dictionary, to store his preferences. But if he tells us that in his kitchen for cumin, turmeric, oregano, paprika, then we can write this prompt and let's run this to set. And let's now run this to generate the new prompt. And in my F string here, available spices gets inserted over here, which is why the prompt now looks like this. Spices is cumin, turmeric, oregano, paprika. And if I set recipe equals get element response, and let's print a recipe ourselves, then is a Mediterranean tofu and olive stir fry that is, wow, Cuban oregano and paprika and doesn't use any other spices than the ones that he says he has in his kitchen. These short recipes where we ask it to provide a 2 sentence description so you don't have too much cooking instructions. And also maybe try adding a key pair to the dictionary that indicates your favorite cuisine to see if it can suggest a recipe in your favorite cuisine. The nice thing about writing code like this is if, say, Tommy were to run out of another spice, say he used up all of his oregano, then you could delete oregano, regenerate the prompt, and then with this code, have it generate a new recipe with a different set of available spices. Try out different variations with providing different types of data in the available or the food preferences Tommy, or you can change it to your name, food preferences your name, and see what recipes you can get. So you've learned a lot about lists and dictionaries and how you can use them to customize prompts. As a preview lesson, you saw earlier that we had set food preferences Tommy dietary restrictions to be vegetarian. It turns out that there's another way to store this data, which is if we were to say food preferences Tommy, is Tommy vegetarian or not, true or false? And I can store a value with the is vegetarian key to be associated with the value true. And if I do this, then food preferences Tommy now becomes a dictionary with 5 keys, where there's a key is vegetarian that's associated with the value true. And for someone else that's not vegetarian, we could will know how to handle that as well. And it turns out that there are some advantages to explicitly as true false, such as if you want to make sure you really, really keep track of whether or not someone is vegetarian, the right food options available to them. But to learn about all this and how to compare data, which will set us up to let AI help us make decisions, let's go on to the next video. At the end of the last lesson, you saw me allude to a true value variable where we said Tommy is vegetarian is true. In this video, we'll take a look at these true false value variables, which we call in computer science Boolean variables, and see how you can use these variables in Python to compare data with each other. Ask questions like, which number is bigger? And then also to use these comparisons to answer questions about data. Let's take a look. In the last video, you saw me use a dictionary like this one to store Tommy's food preferences. I want to use a Boolean variable to store whether or not he is vegetarian. So I'm just going to comment out this line and let's run these 3 cells like so. And if I now print food preferences Tommy, we end up with this, showing that is vegetarian is true. And we don't need to store the vegetarianism of Tommy under this dietary restrictions key anymore. True, as well as false, are special values in Python. If I were to type print true and print false, you might think that these would generate an error because I didn't put true and false in quotation marks. But if you run this code's actually valid. What's going on here? If you were to check the type of true, the type of true is bool, which stands for Boolean. And if we were to look at the type of false, that too is bool or Boolean. So you've seen integers and floats and strings and lists and dictionaries. And this here is a new data type called a Boolean variable, or bool for short. Just as integers allow only certain values like -1, 0, 1, 2, 3, but not 1.5, Boolean allows only certain values, and those values are either true or Boolean. Let's ask our chatbot. This is named after George Boole, a mathematician who had developed Boolean algebra. And it turns out for computer logic and designing digital circuits. And we'll see later that values are often used in computer programming to help the computer decide, do we take this action or not? Yes or no? You'll see more on the use of Boolean values in decision making later in this course. So to recap, Booleans are a data type, true or false, like the outcome from a coin toss, which can be only heads or tails. And you can think of Booleans as giving answers to yes or no, or to false questions. So for example, if you ask, is Tommy my friend? You might set this to true if indeed yes, and you say, yes, he's a good friend of mine. In Python, we'll often make comparisons between different pieces of data. And when you compare two values, the result from comparing two values is a Boolean. Here are some Python operators for making comparisons. So is one thing greater than another thing? Is something less than another thing? And in code, this is how you write greater than or equal. You write the greater than sign, then the equal sign. This is less than or equal. And something we'll see later as well is use two equal signs to check if two values are equal. So for example, if you want to check if Isabel's age is greater than or equal to Tommy's age, you would write age Isabel greater than or equal to age Tommy. And this expression here will return a value that's either true or false. That is a Boolean value, depending on whether or not age Isabel is greater than or equal to age Tommy. Let's take a look at some examples in code. I'm going to assign is Tommy my friend equals true. And notice that is capital T. And is Isabel older than me equals false. And if I print is Tommy my friend, I get true. And if I print is Isabel older than me, I get back the value I had stored in this Boolean variable, is Isabel older than me? And if I were to ask what's the type of this, you get that this is a bool. Now, let's say Isabel, Daniel, and Tommy are playing a game, and they decide that Gus gets to go first in the game. Here are some things you could do in Python. Greater than Daniel's age, expression returns a bool. So let me print Isabel age greater than Daniel age, and because Isabel is 28 and Daniel is 30, and yes, indeed, that is